Hey, so this video is just a quick overview of some of the problems from the homework that you might be having difficulty with. And so feel free to fast forward through any of these that you understand or just check in for the right answers. I'll try to be short and sweet because you should have already done this worksheet before watching this video. So if you haven't done the worksheet, go do it now and then come back and watch. Okay, so first of all, we have one of these expected value problems. And so it actually says expected profit, but it's the same thing. All right, so we have, how many balls are we starting with? I don't know if you can see me moving my face around. It's just in the way of all the words. Okay, so we have 10, 12. So we have 12 balls altogether. And so I'm going to do this in the color that it says. And so 6 out of 12, well, you know what, before we even get there, we want to do just a basic formula. And so we are going to have everything about the red, everything, well, you know what, let's not even do it by colors yet. Let's just first do it, what are you going to win, because that's positive, minus what are you going to lose. And so where do we win? We win if we have a yellow. So we have yellow is a win. I know that's terrible. I won't do it too much more, but I just want to do it for color's sake at the beginning. Green also wins. So I'm going to add, we're going to add the two wins together. You know what would be really mean is if I wrote the word green, but I wrote it in red. That'd be really messy. Okay, and then I'm going to subtract whatever's going on with the red, because that is what happens when we lose. So, all right, enough with the colors. I'll do the rest in black so it's easier to see. So yellow is 4 out of 12, and I'm not going to care about reducing or near the answer. And I'm probably going to type most of this into my calculator. So if you want to reduce and write 1 out of 3, that's fine. If you want to leave it as 4 out of 12, that's fine too. Times, how much do I get? You know, I like to write the probability second. So let me put the money first. I win $1. Why did I put a dollar sign? I win $1 4 out of the 12 times, because yellow is 4 out of 12. I win, where's green? $7, 2 out of 12 times. So yellow is 4 out of 12, green is 2 out of 12. And then I'm going to lose $5, 6 out of 12 times. And so again, you're welcome to reduce any of those, but since we're just going to put it all into the calculator, I don't feel the need to reduce it. So I have 4 out of 12 plus 7 times 2 out of 12 minus 5 times 6 out of 12. And I did my fraction wrong. Oh man. Oh, good thing you can't see my calculator right now. I really messed that up. I'm just going to delete. All right, 5 times, there we go, parentheses, 6 out of 12. And I got -1. And so the question says, what is the expected profit of one draw? And so here, I'm going to say one draw. Oops, that's supposed to be a W. I think I need another bump. One draw loses. Yeah, I spelled loses wrong. You know what? I am just not winning in the writing department. One draw loses $1. So that's our net profit, is we actually lose $1 per draw. If I was doing 15 draws, I would lose $15. And so with that negative, I'm losing $1. Okay, now on the computer, you might just be typing that in. So kind of keep your eyes open on the homework if you're doing lose $1, which would be the word lose, or if you're doing the minus sign. Next one, it says in a game, oh man, I just cannot read it with this. I have this big bar on the top of my screen, but it has all my Zoom controls and it hides my words. Okay, so again, we have a win minus lose. No colors needed. So it says if you toss heads on a coin and roll either a 3 or a 6 on the die, you win $30. Otherwise, you lose 6. So we know the money. We just have to figure out the probability. I'm not going to figure out the probability of otherwise. That doesn't really mean anything. So I'm going to find the probability of getting a coin, tossing heads on a coin, and rolling either a 3 or a 6 on the die. And then I will factor in everything else into that second fraction. All right, so let's just go over here for a second. And we have our coin and we have our die. So our coin, we can either have, I'm just going to kind of make a little table here. We can either have heads or tails. And then for our die, we can have 1, 2, 3, 4, 5, 6. If I can get heads in a 1, heads in a 2, heads in 3, so forth. Or I could get tails in a 1, tails in a 2, tails in a 3, 4, 5, and 6. And so it says heads and 3. So that would be this one. Oh, come on. You know I like colors. Heads and 3 or heads and 6. So that means 2 of the choices are what I want, or what would help me win. And then how many are all together? There's 6 on top and 6 on the bottom. So 2 out of those 12 choices wins, which means the otherwise, which would be the 10 out of 12 times I lose. There's a total of 12. 2 of them I win, 10 of them I lose. Ready for the calculator? So I type in 30 times 2 over 12 minus 6 times 10 over 12. Nope, I put them both on the numerator. And I get 0. So over time, I neither win nor lose. What a fun game. Have you ever seen National Lampoon's Vegas Vacation? They play games like this and that, where they're like, gamble on rock, scissors, paper, that kind of stuff. It's funny. Go watch it. Okay, this one is tricky because we have to remember, well, let's just go back here for a second. In this one, it didn't talk about any sort of buy-in. I might have had to play $100 just to play this game, and then I win 30, which I would net 30, which would be 130 total, or I would lose 6, which would be $94. Anyways, they didn't say anything like that there, so I don't have to think about it. But this problem, there is a buy-in because we have a homeowner's policy. And with a homeowner's insurance policy, we have to pay money every year. So we are paying into this policy. All right, so we are doing this from the company's point of view. So from the company, win, it's always win minus lose. A win would be no damage. I guess this would really be for everyone, right? Not having your house explode is a win for you, and it's a win for your insurance company. But a loss money-wise for your insurance company would be damage to your house. Okay, so it says the probability of having a home damaged is about 1 out of 1,000. So if 1 out of 1,000 times it's damaged, that means 999 out of 1,000 times there's no damage, because together that makes 1. Now, how much does the company win or lose in this example if it was damaged or not? And then I'll worry about the 300 or the 250 in a minute. Okay, so they get $600 a year. If nothing happens to your house, they get $600. So 999 out of 1,000 houses, they are collecting that $600 and that's it. However, on that one problem, that one damage, or whatever happened to that house, they have to pay or they lose $400,000. Now, remember, the homeowner already gave them $600. So what they're losing is almost all of that. But remember that $600 was still being paid by the homeowner. So they're only only actually losing $399,400 because that would be subtracting the $600 from that insurance policy, or not the insurance payout. Okay, so this is one scenario. They're going to collect $600, 999 out of 1,000 times, but subtract, they're going to lose 399,400 1 out of 1,000 times. Oh man, my calculator says that's too many numbers. And that gives me $200. Okay. However, the question says if the company were to sell 250 policies. So I need to take that 200, which is for one time, and I need to multiply it by 250 policies. And because obviously an insurance company isn't just dealing with one customer, they have many customers. And so that would give them $50,000. And that's a win because it's positive. So they would gain $50,000 out of 250 policies because of course, accidents happen. There are going to be some payouts, but the majority of the time they're collecting that money. And so even though that payout is what did I just do? Is very extensive, they still end up making money. And you should look at the answer and be like, obviously they are making money because if they weren't, how would they be in business? So it makes sense. This last problem didn't really make sense, but it never really made sense, right? Like who's playing this game? So the fact that the net profit was 0, I mean, who's playing flip a coin and roll a die? Okay. Next topic has to do with the significance level. So it says Braden tossed a coin 500 times. Now remember, we are not looking to calculate anything. We're not looking to infer anything. We're just determining the meaning of the significance level. And we're going to do this a lot more in chapter 8. But right now, since it talks about this point, the probability of this occurring by chance is 0.01. We would say that at the 0.01 significance, the coin is likely not fair. In other words, let's just think about this for a second. You flip a coin and it lands on head over 4. You do it 500 times, it lands on heads over 400, over 5. Slow down. You flip a coin 500 times and it lands on head over 400 times. It's likely not a fair coin. So that answer makes sense. But this kind of answer and this kind of answer are not looking, that's not what we're looking for in these problems. We're looking for that statistical significance. And so really all we're comparing is the 0.01 to the 0.05. And since they gave us 0.01, we have to go with 0.01 in the answer. So that's, I know it's a lot of words, but I'm trying to help you wade through it and kind of look at what's important. All right. Oh man, I said I was gonna put a blank page so I'd be able to scroll up at the bottom. I don't know, maybe that was a different class. Anyways, I can't scroll up anymore. But here we have a whole bunch of words and I kind of fast forward to the end where it says the difference is significant at the 0.05 level. So going by our pattern, we know it's the bottom one because that is the question that has the 0.05. The first two don't even, what is this? That's not what we're talking about. We're talking about statistical significance. So we're not talking about what do we expect. Is it unusual? We're not going that far into our analysis. We're at like day 1 or day 2 of our analysis. So we're really trying to compare the 0.01, oops, just tried to erase it with my finger like it's an actual whiteboard. The 0.01 to the 0.05. And since it gave us the 0.05 in the problem, it's gonna be the answer of the 0.05. All right, email me if you have any more questions and I will see you in the next video. Bye.